Welcome everyone to our Hangout for the Google Science Fair and LEGO. We want to welcome everyone who's joining us from around the world, some people who are live with us here today in the Hangout, and many others of you who are watching the live stream. My name is Tia, and I work on the education team here at Google. And before we do some introductions, I just wanted to remind everybody why we're here talking about this today. Well, firstly, it's National Science and Engineering Week in the UK, and we think it's very important, of course, to honor and celebrate the work of scientists and engineers of all ages. So we're going to be looking today and learning from some students, researchers, teachers, educators, people who, frankly, just love Legos and have managed to incorporate this love of creating and building into the work they're doing and into the studies they have. We're also here today because there's still a few weeks left for young scientists around the world to apply to the Google Science Fair. Along with LEGO, CERN, Scientific American, and National Geographic, Google is convening the world's largest online science competition. So students who are 13 to 18 can apply by April 1st, and we'll tell you more about that just at the end. Well, even though it's National Science and Engineering Week, we of course think that it's actually good to celebrate science, engineering, technology, and maths year-round. And so we've convened some people here today to hang out with us. So I would love to go around and just have everybody introduce themselves who are on the Hangout. We'll start with Daniel, and if you could tell us who you are, what you do, and where you're joining from today.
Hi, I'm Daniel. I'm a PhD student at Cambridge University, and I'm looking at new ways of creating artificial bone and other biological tissues that we could then use to replace tissues at the bottom in the body. And I'm joining from Cambridge in the UK.
Thank you very much. Henrik?
Yes, hi, my name is Henrik Hogard, and I'm a project manager at LEGO, what we call the Novelty Project Manager. And one of my tasks has been actually bringing this guy just behind me to life back in 2009. So my normal job is actually to develop new fun toy for kids, and of course stuff that could be used in education as well. And my second job is keeping the Mindstorms products safe and sound and running. And I'm calling in from Denmark, a little town called Billund, where LEGO actually comes from.
Excellent, thank you. Now let's hear from the class who's joined us. Thanks to Mr. Holt and Mr. Richardson. If you could introduce yourselves, please.
Right, we are the Commissari School. I'm Miss Stabellini, and well, these are some of my Year 9 students, some of the brightest ones, obviously.
Welcome to all of you. Mr. McLaughlin, you also have your class here. I think you're just on mute, Mr. McLaughlin.
Sorry about that. Hello everyone, my name is Mr. McLaughlin. I'm a Year 4 teacher here at Broughton Astley at Old Mill Primary School. I've got 28 children sitting on the floor here from the ages of 8 to 9 who are joining us today, so we're really looking forward to this.
Wonderful, thank you. Okay, Kenneth Lhasa.
Yeah, hi, I'm Kenneth, and I'm from Aalborg. I'm studying software engineering at Aalborg University, and have used LEGO Mindstorms in a couple of my projects.
Yes, and I'm Lasse. I also come from Aalborg University in Denmark. I study computer engineering, and I've also used LEGO for a lot of my projects as well.
Excellent. Thank you. Rita, would you like to introduce yourself?
Oh, yes. Can you hear me well? Okay, well, it's nice to be here. I'm Rita from Argentina, and I am a teacher of English as a foreign language, and I love all Google applications, and this is why I'm here today. And in fact, at the moment, I'm also training colleagues in my place to integrate internet tools into language learning. It's
Excellent.
A pleasure to be with you.
Thank you. And I see that just in time, we have Luke, who's joined us from South Africa. Thank you so much for making time to get over here. We know you were busy today. So if you could tell us where you're joining from and a little bit more about yourself, Luke.
Yeah, sure. I'm from Cape Town, South Africa, and I'm joining this Hangout.
Yeah.
I was a finalist at the Google Science Fair last year, with a project about programming robots in English.
Excellent. Thank you. Well, let's get started here. What we're going to do, we're going to hear from a number of people throughout this Hangout, and then really encourage people to jump in with questions as they have them. We're going to start with Henrik, who, could you tell us just a little bit more about the ways you see people using Legos in education, not just for play, which of course is how many of us came first to know Legos?
Well, first of all, Lego is living on the strange boundary between play and learning, actually. It's one of our, core goals in life is actually to go even further than just play, that you actually learn by playing. And especially the stuff that I'm dealing with, Mindstorms, which has been around for like almost 12 years now, was actually born as a educational project. When I say we need to make something that actually can teach kids everything about science and technology in a fun way. So we invented this system, and it's been growing ever since. And many of you might know the stuff from First Lego League, and from some of you hopefully from at home as well. And right now we just see this stuff being used, almost everywhere, even in Cambridge. I know that every student that's going through a engineering class in Cambridge, the first week they spend there is actually Mindstorms, because it gives a pretty good, solid background of what robotics is all about. So that's what we play with. And,
excellent. Could you tell us more about that guy who's behind you there?
Oh, yeah.
Actually, sorry, I can't tell if it's a guy or a girl from here.
It's just a robot. You can put on it if it's a he or she. It's up to you. No problem. We just call him Alpharix. He's actually the second generation of Alpharix. And he was actually born in 2009 as the second generation of the NXT. And I was project manager on that one. And already at that time, we were playing around with the idea of using it big time in schools as well. So we actually have a segment at Lego called Lego Education that does products that is specifically made for school use. And I would assume that a couple of you already know that set in your daily work. But what we do as well is, like Lhasa and Kenneth, we have others of what we call adult fans of Lego, AFOs. And that built with this stuff, and never stop playing with it. Just like me, I never stopped playing with it either. But we actually challenge some of these guys on building some big, really show-off model for shows of different kinds. And I hope you can actually see it. I'll try to show you a picture of it here. What it is actually a massive construction that we made back in 2009. It contains approximately 400,000 elements and 30 NXTs, and actually is a fully workable, functional model of our high bay warehouse here in Billund, which means that's where we store all our Legos before we actually start packing them. This one is, of course, not as big as a real one, because that contains approximately 800,000 small pallets in there, but this one is like 500. It's fully workable. And after we have been spending some time using it at different fairs, it's now parked in a university in Lissing in Holland, where they actually use it for training students on how to optimize logistics, software, transport, mechanics, and stuff like this. So it floats in everywhere.
Excellent. Very cool. Well, I like that term, adult fans of Legos. Well, let's hear from one, not just a fan, but somebody who's really using it in the work with he and his team, and that's Daniel up in Cambridge. We're just going to watch a few bits of a video, which many of you may have seen on the Google Science Fair page or on YouTube, just to see a little bit more of the work in action, and then Daniel will tell us a little bit more about it.
My name is Michelle Oyen, and I'm a lecturer in the Department of Engineering at Cambridge University. We're very interested in bone because it has excellent mechanical properties for its weight. Without your bones, you would be a pile of goo lying on the floor.
I'm Daniel. I'm a PhD student studying at Cambridge University, and I'm investigating ways in which we can create artificial bone. We could use it for a variety of different applications. Implants is the obvious one, but also it could be used as a material in buildings. So in order to make the bone-like substance, you take a sample, and then you dip it into one beaker which contains calcium and protein. You then rinse it in some water, and then you dip it again into another beaker that contains phosphate and protein. You have to do it over and over and over again. When I started the project, I started thinking about how we could actually automate the process. There are a variety of ways you can automate. You can buy very, very expensive kit off the shelf, but Lego seemed like the simplest way. The great thing about the robots is that once you tell them what to do, they can just do it very precisely over and over again. So a day later, they can come back and see a fully made sample.
Research is a funny thing because you might think that we order everything up out of scientific catalogs, but actually a lot of the things that we use around the lab are household items, things we've picked up at the local home goods store, and so our robots just fit in with that mindset.
Excellent. Great. So, Daniel, how did you get this idea to use Legos to help you with this?
Well, originally when I was doing it, I had to do it by hand, and so I'd have my eyes glued to a stopwatch, and every minute then have to just move a tea strainer from one beaker to the next beaker, and then do that for an hour. And inevitably, after about 5 minutes, I have drifted off and noticed that the clock is actually reading 5 minutes and 30 seconds rather than 5 minutes. And so it wasn't accurate. I had to be there for a very long time, and so looked at ways in which we could automate it. And the great thing about Lego is you can just put something together really quickly, especially with the Mindstorms, and program it and get it to do what you want to do, and then you can gradually tinker with the design as you're working with it, just to keep on improving it, until it works just the way you want.
And is that your robot back there?
Yeah, this is one of the robots that we've got in the lab. So it's a very simple crane. That's all there is to it, but it does what it needs to, and I don't need to be there, and it does it a lot more accurately than I could do it as well, because it doesn't fall asleep.
Cool, excellent. Well, let's hear from a few of the other researchers and students, and then we'll open up to a bunch of questions. Let's hear from Kenneth Lhasa. We would love to learn more about how you've been using Legos.
Yeah, thanks, dear. I'm going to share screen. If I'm allowed to do. Oh, well, just a second. Here.
They're going to show us a video. Here we go.
So you can see the image. So at my 5th semester, I'm currently at my 10th. So at my 5th semester, we have a topic called real-time software, and a real-time software requires some system to be able to monitor and then react to what it monitors. An example is the anti-lock braking system in cars, where a sensor monitors if the wheel are turning while braking, and if it's not turning, then it releases the force, the braking force applied to the brakes, in order to have maximum grip, and reduces the braking length of the car. So that's a real-time system. So what we did to learn how to program a real-time system was to build a package management system that like schedules packages from 3 conveyor belts, as you can see in the picture. So we have these 3 conveyor belts that has slots with package on it. And then the red packages are prioritized in a way that they should be onto the master belt and faster than a regular package. And so it's a scheduling system for 3 conveyor belts onto 1 master belt. And I'm going to show you a video of it, just to see how to.
Great, thank you. Thank you.
And then this one, right? So I should share, and then I'll play the video. And you can see, yeah. So now it scans every package to see whether it is a prioritized one, and then the red ones are prioritized and should become before the white ones. So yeah, so that was the system we developed at my 5th semester.
Wow. How did you get the idea to incorporate the Legos in this way?
Well, that's because, well, I'm a software engineer, so I don't understand anything electronics and stuff. So Lego Mindstorms provides this very easy platform to base our to code to. So that's just, yeah, what we think of that time.
Great. And if you want to turn it off screen share, and then we can see both of you again. So do you work together on this work?
No, that was only my project at school. We don't have the same education. So.
Excellent. Okay. And Lhasa,
You want me to go on?
Yeah, please.
Yeah. Well, now I'm more the electronics, you know, every hardware that's in the NXT. So the NXT is kind of like a finished platform for my education. And I'm just going to show you a video. Like Henrik talked about, in my education, we also start with a big robotics competition, where actually everyone that starts on this education has to complete this course of sorts, where we have to build a robot that should complete different tasks. So here you see us tilting a bottle, and later on we're gonna right here we're gonna bowl with the robot as well. So yeah, everyone that applies for my study has to do this as their first semester, just to kind of get to know robotics. And as Henrik says, that's where the Mindstorms comes in, because it's just such an easy platform to start building with and creating with. You can, yeah, it's plug and play. You know, you pour the box out there, start building and start programming and play. So now to upgrade this, I did on my 2nd semester, we were supposed to do autonomous vehicles. And building an autonomous vehicle,
and
you
what
know,
does
the hardware.
Mean, autonomous vehicle, for the people who don't know?
You know, a vehicle that can drive by itself.
Okay, without a human.
Without a human, yeah. So, like your GPS navigation system, it tells you when you're driving around where to go. This one just does it automatically. So it uses the GPS signals and drives around a course. So what we did was build a Lego robot. I'm just gonna find a picture for you very quickly. Right here. So this was our robot for my 2nd semester. As you can see, there's a big Lego platform on it with a laptop. And what we did was just use the Lego as a vehicle platform for this PC. So the vehicle was meant as a public watch, so it could kind of patrol an area, and if it detected any humans, it'll call back to a security center and tell that it has detected maybe a thief or something. So that was the initial idea.
Wow.
Yeah. So again, a very basic platform that allowed us to quickly make the robot work as a prototype. Here you can see the application where we draw in a route that it was supposed to patrol, so it followed that route around and reported if it saw any human shapes in the camera feed.
Wow, so it's a security robot, just like
yeah, exactly.
Read about it.
This was actually the great part about it, because this allowed us to get a company sponsored for our 3rd semester. Because we had this Lego prototype, a company got interested and sponsored an ATV vehicle for us. So our 3rd semester was actually to implement this Lego robot onto a real, you know, big-sized robot. So we built this ATV to drive around with the GPS signal and monitor areas.
Wow. Thank you for showing us that. Before we hear from a few more folks like Luke, do any of the students have any questions that they'd like to ask?
Do you think people understand that it's science you're doing here, not just playing around and like having fun?
That's a very good question. Daniel, what do you think? How do people know you're not just messing around?
Yeah, I do. I mean, it's a difficult one because we are using Lego, so we are having fun. But at the end of the day, we can produce something which is a little bit small. I don't know if you can just see it in the camera, but it's actually quite tough and a lot like bone, and it does make some advances in the field. So it's you have to. I guess you have to advertise both in a way. The Lego gets people interested, but then the bone's where the advances are.
Okay, Mr. McLaughlin, I think a student in your class has a question.
Yeah, I'll just introduce Emily for you. Emily, come on in, please. I think this has been aimed at Daniel, okay? A big voice there, Emily. Enter. There she is.
What have you got planned next?
Well, next, there's another student in our lab who's working on a similar project, and he's actually built a completely new Lego robot to modify the process, and he's going to be looking at whether we can coat implants that would go into your body, like steel hip replacements, and coat them with this bone-like substance to see if he can make a nice interface between the engineering materials that you would put into your body because they're very strong, and then the very soft biological tissues that sit right nearby.
Okay, so that's something that can really help people who've been injured then.
Yeah, that's the aim, is...
Great, thank you for your questions. That's great. What about you, Kenneth and Lhasa? Have you seen a lot of other, maybe younger students coming to learn about what you all are doing there?
Well, yeah, we have. I'm also, what do you call it? I arrange robotics competitions for younger kids. I actually, in about a month's time, have a big competition where about 20 primary schools, I think you call it, come here to learn about robotics. Just where we learn them how you can play with it and still learn science.
Excellent. Great. Okay, well, let's hear from Luke now. Luke, as he said, was one of the 15 finalists in the 2011 Google Science Fair. And Luke, we'd love to hear a bit more about your project. Some of the people may have seen your video, and we'll certainly circulate that after the Hangout to others. But could you tell us a bit about what your project was?
Yeah, sure. My project was about programming robots in English. And how I came to this question, okay, to cut a story short, I've got a friend, his name's Timbela, and he got this Mindstorms kit from Lego, and he really liked it, but he struggled programming his robots, but he really liked building his robots. So I thought maybe he could program his robots in English, since he knows this compared to computer language. So yeah, that's embarked on this project, programming robots in English, and yeah.
Mm-hmm. Did your parents think you were just kind of playing with the Legos, or did they get that you were doing science?
I'm not sure. At the beginning, they thought maybe I was like more playing with Legos. They said like, really concentrate on your schoolwork, don't spend too much time with the Legos. You know, after school, I'd always spend like at least an hour or two programming, building with the Legos, working on the project. And then when I made the semi-finalists, they were like, okay, yeah, cool, just stick with it. Yeah.
Excellent. And do you, I don't know if you have any of your robots there with you today, or if not, we can see it on the...
Yeah, I've got two with me. So, let's see. So this is the one I had in California last year at the exhibition. His name is ECR, which stands for English Controlled Robot. I wanted to make a fancy name, and his like human name is Bobo. Yeah.
Okay.
And so what you
could... a human name.
Oh my gosh. You could like hook him up to your computer. Well, there are two NXTs in here, so they'd both connect with each other, and then yeah, you'd connect it up to your computer, and you'd like type robot, go forward until you hear a sound, then reverse for 5 meters, or you know, whatever you'd like. Yeah, that's that guy. And then this is the default robot that you get with the Mindstorms set. And recently I've been playing around with the Wii board and the Mindstorms, controlling the Mindstorms with the Wii board. And there's a video on YouTube that you can have a look at if you want later. Yeah, and those are 2 robots I got here.
Excellent. And are you still carrying on your work even after the science fair? Because the finals were last July. Have you continued to explore the robotics?
No, I haven't continued working on the project, controlling the robots in English. I guess there's a lot of schoolwork, and committing yourself to a science fair it's a lot of work, a lot of sleepless nights. Yeah, so I thought this year I'd just give it a short break, and definitely next year I'll be taking part again. So yeah.
What would be your advice to students who are working on a science project, whether it's a robot or not? Maybe it's the Google Science Fair, or maybe it's just for their classwork. Do you have any tips for them, maybe from your experience last year?
Yeah, I guess the question that you're asking yourself should be in a way unique, and really it should really interest you, yourself, and you should be passionate about the topic that you're investigating, because there are stages where you'll just think like, oh my gosh, this is not working out, and yeah, you must be ambitious, stick with it, and yeah, have fun.
Great. Do we have any other questions from some of the students, of any of the folks who are with us today?
Luke, I've got a question that was given to me by the children in my class. Unfortunately, they've all had to go home. Nobody left in the room. One of the questions for Luke is, when did you come up with this passion for Lego? Was it something that you started when you were very young?
Yeah, it's something that started a few years ago. I was about this size, maybe. My parents got me some Legos, and since then I've been hooked. I've been building Lego cities with the train and stuff. And then about 6 years ago I got the Mindstorms. And yeah, that's where I really found my passion for robotics and programming.
So you could say that children who have a passion for Lego now, to continue with that passion, parents, teachers should let them blossom and use that passion, use that ingenuity to push their boundaries in science.
Yeah, sure. Legos is one of the greatest inventions ever. Greatest toys. You can spend hours and hours playing around with it. I mean, even engineers these days at universities, they stop playing around with the little Lego bricks. Yeah, it really challenges your mind, I guess, you know? Yeah, it's really fun. Yeah, I think they should.
Excellent. Thank you.
Thank you. And in fact, the founders of Google were lovers and still are of Legos. And there is a story which I understand is true, which is that Google got our colors, the red and yellow and green and blue, inspired by Legos with the color there. And you know why, right? Okay, are there any other questions here for the for some of our students and our researchers? Rita, yeah, sure, please.
Oh, yeah. Maybe Alan, how long does it take to make a machine like that, to make a robot like that, please?
Okay, and that's for Luke, actually. How long did it take you to make maybe the first robot, and then how long did it take for you to make your robot for your science project?
Okay, so the first robot was basically the default robot you got with the set, which, like it says on the box, took 30 minutes. And yeah, and then I thought it would be cool to show my own robot at the science exhibition. So I built this robot, which took about 2 months, I guess. You know, designing it, constructing it, because it takes some time. Yeah, and especially with this cool outfit it has, I was thinking, yeah, cool.
Great. Is there another question there from the students who are at Thomas Hardy?
Yeah. What, out of all the things you could have used, why did you choose Lego?
Let's start with maybe Kenneth and Lhasa for that one, and then we'll hear from Daniel.
Well, the reason we chose Legos was that I have been building with Legos since I was born, actually. I've always used Legos for everything, and so I consider myself to be quite a good builder. So what the others in my group came up with, the idea of building this package management system, I said, yeah, sure, we can do it. I can build it. So that was the reason to do Lego. So.
Yeah. Well, I actually grew up with, my father was a mechanic, so I learned welding and, you know, mechanical construction with iron and wood. But again, if you want to build like a Lego beam out of wood or iron, it just takes so long time to do it. Again, Lego has the modules. You just put them together.
Well, we have a question here from one of the people who's watching, who's not on the Hangout, Scarlett Wilson. And this is for anybody who wants to take a stab at answering. She's wondering, you know, is the world going to end up like the movie WALL-E, where, you know, machines are doing everything for us, and there are robots all over the place? What do you think? Maybe, what do you think, Daniel?
That's a tricky one. I certainly think they're going to keep on playing a much bigger role in things like the navigation systems in cars are going to get a lot more sophisticated, so you can start talking to your car and things like that. But I think at least for the foreseeable future, there'll always be a nice role for humans to actually still do a lot of things and come up with ingenious and creative solutions.
What do you think, Henrik? I'm sure you must be aware of some of the most interesting and kind of groundbreaking work that you see with robots. What's your view?
Well, first of all, the first question you always have to ask, when do you define something as a robot? Because we're surrounded by technology every day that you know, do a lot of things automatically for us, and we actually don't even think of it. So when we start looking into like robots, as the guy I have just behind me here, or something similar, well, it's up to us how far we want to go, because I'm sure that then in 20 years we will see human-like robots helping us out in all sorts of ways, and we've seen the first ones already, and they're coming in big time. So it's more a question about the humanity, the human race as such, saying, well, enough is enough, and simply stop there. I think that we should explore whatever we can in terms of robotics and see how far we can go. Because, of course, there will be points of, yeah, are we getting a little bit too far here? But on the other hand, if we're not trying to figure out what we can do and actually try out the boundaries of all this, we never really get to the point to say, wow, this is cool. This can be used for numerous stuff. So why not just continue? And actually, I want to put one single comment to one of the questions before, is about Legos and you know, science and technology, and what's the difference between playing and science, and why should it actually be boring to deal with science and technology? Why not just play your way into it and learn through playing? Do it, because you know it's not a question of just sitting there putting figures into computers or putting figures on a piece of paper or drawing up time. Build it, try it. Just building prototypes is actually a freaking good way to figure out whether things are good or workable or not. So I would say just go for it, and don't be afraid of just using robots wherever you can. We'll find a way to say stop if it's going too far.
Excellent. Thank you very much. I think we're going to have to wrap up now. I want to thank particularly the schools who joined us today, and also our scientists from Cape Town, from Cambridge, and from over in Denmark, our guests who came far and wide from places like Argentina, and all of you who watched the live stream of this Hangout. For those of you who are interested in learning more, please do visit the LEGO website or talk to your teachers and your families. If you're interested in applying for the Google Science Fair, the deadline is April 1st, so it's not too late. You don't necessarily have to have a project about Lego and robotics, although you might. And you can find out more about how to apply by visiting google.com/science fair. And again, that's due on April 1st. You can apply in one of 13 languages, and that's for students who are 13 to 18 around the world, but please make sure you check the website for your eligibility. Thank you very much to everybody who joined, and I hope everybody enjoys this National Science and Engineering Week in the UK, but that every week is a celebration of science and engineering. Thanks very much.
Bye. Nope, thank you. Bye-bye.
Cheers.